Well, good evening, and this is going to be the first of several or many live streams over the course of this semester where I'll be just getting on the camera for an hour or two on usually on Sundays and just give you some either a recap of what we did the previous week or a preview of what we're going to do the next week in some of my classes. So right now, what I think we're going to do is we're going to work on, hang on here, start this up. We're going to do some Java, although I'm not quite sure if, let's see, are we actually live? Yes, we are. Good. This is the first time I'm doing this since the winter break, and so I'm trying to get my setup running again. Okay, so what we're doing today is kind of a review of Java conditionals, loops, and arrays. So I thought that we could work some problems on just doing some live Java coding. And then after we do some of those, I can talk to you about some of the conceptual models. That is how you should be picturing your program in your mind or on a piece of paper as you're writing your programs. Okay. So it looks like we've got 2 people watching right now. I think one of them is me. So hopefully we'll get some more people over the next hour or so. So why don't we go to the CodingBat website, which is one that I had showed you. And this is a website, if you're not familiar with it, where you can go and just try out some Java code. They got tons of programs that you can try out. This is just the section on working on with arrays. If you go into the Java section, you can see there's a huge number of things you can do here. So what I thought we would do is this one called sum28 first. And in this one, it says here, given an array of integers, return true if the sum of all the 2's in the array is exactly 8. So we want to add up all of the elements in the array, like here. And if the sum of all of the 2's, this one, this one, this one, and this one, if those add up to 8, then we want to return true. And if they don't add up to 8, we want to return false. All right, so this one's pretty straightforward, I think. We're just going to run through the array, left to right, and then as we sum up all the numbers, actually we're only going to sum up the 2's, and if those add up to 8 when we're entirely done, then we'll return true. So I think we'll just kind of do our standard loop over an array. We can see that we're being passed in this array in a name called numbers or nums. So let's just do our standard loop. For int I equals 0, I is less than nums.length, I++. And I like to put in the braces right away, just so I don't forget to put in the closing one after typing the opening one. And then I'm going to add up the numbers, but I only want to add up the numbers if it's a 2. So something like if nums bracket I is a 2, then increment the sum. So we can go sum equals sum plus nums bracket I. And it turns out we're going to need a variable to hold that sum. And since we need that sum during the entire loop, and we're also going to need to look at the sum after the loop, we need to declare it outside the loop. So over here, we go int sum equals 0. So we'll initialize it to be 0, and then we'll start our loop. So this should increment the sum only if the number we're looking at is a 2. And then when we're all done, we'll say if the sum is equal to 8, we'll return true, else return false. All right, I think that'll do it. Let's give it a try. We'll just click on go. And I'm going to have to move my window over so you can see the results. But here it is. I think you can see that. Yeah. What we got here is all green, indicating that, in fact, everything worked out. Now let's see if we can do something about making this program a little bit simpler. One thing we could do is, rather than returning true if the sum is equal to 8 and returning false otherwise, what we're doing here is we're saying return true if this condition is true, else return false. So if true, return true, else return false. We can shorten that by just saying return sum equals 8. So if this condition evaluates to true, we'll return true. And if it evaluates to false, we'll return false. So let's give it a try. And I'll bring the window over. We can see that we've got all greens as well. So what we did there was something called refactoring. We refactored the program. We made a modification to the program. We didn't change the behavior, so it's not acting different. It's not returning different values, but we changed the behavior so that it works a little bit better. So let's try another program. I want to do has 28. Where is that? Well, I saw it a moment ago. Oh, sorry. Has 22. I think that's the one I want. Has 22. So given an array of integers, return true if the array contains a 2 next to a 2 somewhere. So if there's a pair of 2s somewhere in the array, then I want to return true. Now, by the way, if you are tuning into the stream and you want to ask a question, there should be a chat window over to the right-hand side, and you can ask a question there. If you're on a mobile device like a tablet or a phone, then I'm not sure if the chat window appears by default. I think that there's a way to bring up the chat window. It like appears behind it's like at the very bottom of the screen. It says show chat or something like that. Anyway, feel free to post a question if you have one. Okay, so we're going to be given an array of integers, and we want to return true if the array contains a 2 next to a 2 somewhere. All right, so again, sounds like kind of a loop. We need to loop through the array, and we need to look for pairs of 2s. Let's look at some of the examples here. So here's a 2 next to a 2, which return true. Here's a 2 that's not next to a 2, we'll return a false. And here's also a 2 that's not next to a 2, we'll return false. So what we need to do is, as we're looping through the array, when we look at one element, we need to look at the very next one and see if there's a 2 next to it. And actually what we can do is, as soon as we find a pair of those 2s, we're done. We know that we have a 2 next to a 2 somewhere, and we can actually stop looking at the rest of the array. So let's go ahead and write our loop for int I equals 0, I is less than nums.length, I plus plus. And then we'll say if num sub I is equal to 2 and the very next one, num sub I plus 1. If that one and the very next one is equal to 2, then we're done. We can just say return true. We found a pair of 2s. We're done. And then at the very bottom of this, we'll say return false. If we get all the way through the loop and we never returned out of it, we're going to return false. Now, here's something that I've discovered may be a little confusion for some people, is that once you execute this statement, return true, your entire method is completely done. Nothing else will get executed. So this method here will not like somehow simultaneously return true and false. As soon as it returns true, it is done. The loop will not complete, and this return false will not happen either. So let's try it out. Okay, we got some errors on this. Let's see what it says here. Okay, so we got some conditions or some tests where it worked out okay. Like it worked out okay for this one. This one here got an array index out of bounds exception. For some reason, we walked off the end of the array. Same thing with this test here. This one worked out. So actually, all the tests where it worked and where it didn't walk off the end of the array, those worked out just fine. It was the ones where we walked off the end of the array. And I think I know what's wrong. The problem happens, like look here. Right here, the second one here. The array is 1, 2, 1, 2. So we look at as we're looping through the array, we look at the first element, the number 0 element, and the one next to it. So we look at the 1 and the 2, and those are not a pair of 2s. So then we move on to the next one. We look at the 2 and the 1, and those aren't a pair of 2s. Then we look at the 1 and the 2, and that's fine. And then we look at the 2 and the 1 after it, and there isn't one after it. So we end up walking off the end of the array, and this gives us our exception. So to fix that, we actually shouldn't loop through the entire array. We need to stop just before we get to the end of the array. All right? So we're going to start at the 0th element, but we're going to stop at the second to last element so that we don't try to look at the one beyond the last element. Let's try that. And that one worked out okay. All right, so that's something to keep in mind, is that if your problem requires you to look at several elements sequentially, you need to stop looking before you get to the end of the array. Otherwise, you'll end up looking beyond and going off the end of the array. All right, let's try another one. Let's do only 14, which is this one right here. Given an array of integers, return true if every element is a 1 or a 4. All right, so this one is true because all the elements are 1 and 4. This one is false because there's a 2 in there. They're not all 1s and 4s. And this one is true because there's only 1s, but that means that every element is a 1 or a 4. All right, so this is not a problem where we're looking at pairs of numbers. We're just looking at each individual number and determining if they're a 1 or a 4. So if they're all 1s or 4s, then we return true. If they're not all 1s and 4s, we return false. So I can think of actually several ways to solve this problem. So one of them, we could do it this way. One of them is we'll add up how many 1s and 4s we found. And if the sum of that number, we're not adding up the 1s and 4s themselves, we're adding up how many of them we found. And if that's equal to the length of the array, it must have been that they're all 1s and 4s. So let's do it this way. Let's initialize a count. Let's call it count14. And that's initially going to be 0. And then we're going to do our loop. Standard walking through an array loop. And then we'll say if num sub I is equal to a 1, or num sub I is equal to a 4, then we'll increment the count. Okay, so if we ran into a 1 or a 4, we'll count them up. And into the loop, we'll say if count, this should be count14. Count14. If count14 is equal to the length of the array, then that's true. And hold on. Remember what I said about 15 minutes ago, that if you're evaluating a condition and you return true, if the condition is true, why not just return the condition itself? So let's do that. Let's go return like that. So return whether or not the count is equal to the length. So let's try it. Okay. Pretty good. All green. So all those tests pass. So that was one way to do it. And then I thought of a different way. So let's get rid of this. What we're going to do is we're going to loop through the array we did before, but what's happening is as long as we encounter 1s and 4s, we'll just keep going. As soon as we hit something that's not a 1 or a 4, we'll get out. We know at that point that the array does not contain all 1s and 4s. So here's our loop for int I equals 0, I is less than nums dot length. So the usual loop. And we'll say if num sub I is not equal to a 1 and num sub I is not equal to a 4. So if it's not a 1 and it's not a 4, we'll immediately return false. So if we encounter a number that's not a 1 and it's not a 4, so be clear there on what the conditional should be. It shouldn't be an or, it should be an and. It's easy to say in English, if it's not a 1 or a 4, return false. But in logic, that should be an and. If it's not a 1 and it's not a 4, return false. And then if we get all the way through the loop and we never return, we'll just return true. All right. So I just clicked on go, and then I got all greens there. So this is a valid way of doing the same problem, but without counting anything up. Now, what I want to point out is one of these tests is kind of interesting. It's this one right here. This one says we're passing in an array with nothing in it. There's no elements. And that should return a true. Does that seem kind of strange to you? That an array that has nothing in it should be true. And if you look back at the problem statement, it says, given an array of ints, return true if every element is a 1 or a 4. And you might look at that and go, well, it's not true there that all the elements are 1 or 4 because there's nothing in it. But this is a kind of a direct consequence of the way we wrote the program. The program assumes that all of the elements are a 1 or a 4 and returns false if it finds anything out of the ordinary, anything that's not a 1 or a 4. So the default value, kind of, you can think about it, the default value for this function or this method is to return true, but return false if there's some kind of exceptional case. So what's going to happen if the array is empty? Well, so this loop starts at 0, and then it sees whether I is less than the length of the array. Now, the length is going to be 0 in that case, so this condition is going to fail immediately. I is not length less than the length. It's equal to the length. So it never enters the loop. It immediately goes down to return true, and it never looks at any of the elements of the array. So if you had thought about this case and figured if there's no elements in the array, then I should return false because they're not all, clearly not all 1s or 4s, then what you end up having to do is put in maybe a special case, like if nums.length is equal to 0, so if there's no elements, then return false. And then when you run it, you see that you end up with a red right in that spot. So you end up having to put the special case in there. Alternatively, you might do something like assume that the answer is false, like Boolean all 1, 4 equals false, and then somehow have to write the loop so that you turn that Boolean to true if you encounter all 1s or 4s. So it really actually makes the problem a little more complicated if you do it that way. If you assume that the answer is false and then attempt to make it true later on. It's much easier to write this program if you assume that it's true and then see if it's false by finding a counterexample somewhere in there. All right, so if you do it the easy way, and you make the assumption that the answer is true, it so happens that all the tests pass exactly the way they want. All right, let's do another one. Let's do without 10. Let me find it again. Here it is, without 10. All right, this one's a little more complicated. So return a version of the given array where all the 10s have been removed. The remaining elements should shift left towards the start of the array as needed, and the empty spaces at the end of the array should be 0. So an array of 1, 10, 10, 2 should be 1, 2, 0, 0. So the 10s are gone. The 1 or 2 have been moved down into the starting positions, and the zeros have filled up the rest. And it says you may modify and return the given array or make a new array. And I want to write the program so that we make a new array rather than modify the array. Okay, so this function doesn't return a true or a false or a count. It returns an array. And we can see that here in the return value. Integer array, public integer array without 10, and then you're given an array called nums. So the first thing we need to do inside of this method is to make a new array that's the same size as the one we're given. So the way we do that is let's go integer array, that's the type, and we'll call it ARR for lack of a better name, equals new integer array. And then inside the brackets, we need to put how many elements. And we want to have the same number of elements as in the nums array. So we can get the number of elements by asking for its length. So that should now give us an array, ARR, whose size is the same length as the nums array. And when we started out, actually, all the elements have been set to 0 for us. So that kind of handles half the problem for us, which is how to get the remainder of the elements to be equal to 0. They already are equal to 0. So all we have to do is move everything down. All right, let me switch back to this screen here. And let's draw some pictures. So let's say we have this array. Let me put some boxes in there. So we got 1, 10, 5, 10, 2, 4, 10, 6, 1, 8. Okay, so that's our nums array. And then we have a new one that's the same length, and this one's called ARR. And we want to move the elements or copy the elements from the nums array into the new array, but ignore all the 10s. So the 1 should come down. The 5 should go into the next slot. The 2 goes in the one after that. The 4 goes here. The 6 goes there. The 1 goes there. Yep, and the 8 goes there. And you can see the 3 10s have been ignored, and then these will just be filled in with the zeros that are in fact already there. Okay, so how do we do that? So what we need with this is a loop that walks through the nums array one at a time, looking at each one of the elements, but then we're only going to copy that into the new array, ARR, if it's not a 10. So we're actually going to need 2 loop counters, or 2 counters. One of them is going through the nums array from left to right, looking at all the elements, and the other one is going through this new array, but only incrementing when we've copied a value in. So this is going to be a separate counter. We can't use one counter to do both. And this is actually also not going to be a case of having a nested loop, because we're not processing one array for every element of the other array. That's what you need a nested loop for, is if you want to do an entire inner loop for every one iteration of the outer loop. These are almost going in parallel, but the one for ARR, the new array, is going a little bit slower than the other one, but more or less they're going in lockstep. So that should tell you that there's only one loop, but one counter is going a little bit slower than the other counter. Okay, let's switch back to the web browser. So I'm going to have a loop. That goes from 0 to the length of the nums array. Okay, but I'm going to have another counter. Let's call this A. So this is the counter for the ARR array, and initially that'll be 0 as well. All right, so we're going to do like if num sub I is not equal to 10. So if it's not equal to 10, we should copy the element from num sub I into ARR sub A. Okay, so we're going to copy it from ARR sub A into num sub I. Oh, sorry, I had that totally backwards. We're going to copy it from num sub I into ARR sub A. So ARR sub A is equal to num sub I. So this will copy the elements. Essentially, this is the green arrows that are copying the elements down. Okay, now once we've copied that element, we need to move A to the next slot so that it knows where to put the next element in the new array. So A++. All right, and then we're just going to finish the rest of the loop, and then when we're all done, we'll return that new array. Okay, so let's give it a try, and we'll see if this works. And it does. We got all greens there. And it not only is it nice to see all greens there, but also take a look at some of the tests that were done. Like here's one that was passed in an empty array, and we did correctly return an empty array. And here's one that was passed an array of just consisting of one element, and that one worked as well. Here's one that was mostly tens. Oh, and here's an interesting one. Here's an array that was all tens. There was only one element in it, but it was all tens, and we ended up passing back an array that was just a 0. All right. So again, if you look at this program here, there's just one loop, and it's walking through the original array, and then there's another counter that's more or less copying what the first counter is doing, but just lagging behind by a little bit because it doesn't always get incremented. All right. So for those of you who are curious, there is actually a way to shorten this a little bit. It's not a huge reduction. In fact, you might argue that this makes the code a little less readable. But if you notice here, we're declaring this variable called A outside the loop, but we don't actually need it outside the loop, right? After the loop is done, we don't care what the value of A is. All we're going to do is return this array. So what if we declare it inside the loop? So let's take it out here. If we put it here, int A equals 0, and then we hit go, we can see, uh-oh, that was not good. We ended up actually with a whole bunch of reds. And the answer to that, or the reason why, is because we're creating a new instance of A every time we iterate through the loop. So every time we move to the next element, A is set back to 0. That's not what we want. What we want is a variable called A that exists for the entire loop, but not outside the loop. And the way we do that is the same way we created this variable here. This variable called I exists for the entire loop, but does not exist outside the loop. So little did you know that you can declare two variables up there. So I said int I equals 0, comma, A equals 0. And this will make two variables, one called I, one called A, and set them both to 0. And I'm not going to change the rest of this. But if I click on Go, and then look at my results, it's all green. Okay, so like I said, you could argue this didn't make it a whole lot clearer because I've added a little bit extra here, and I didn't really save a whole lot of coding, right? I saved the word int. But then again, it does make it, if this was a much larger method, it does make it a little bit cleaner because I don't have this extra variable called A outside of the loop where I don't need it. And I'm free then to make a new A later on, let's say, and use it for something else. Okay, you might ask, well, if I can declare a variable called A right here, what happens if I also increment it? Right, let's maybe take this out. Okay, you can do that. It'll compile just fine, but you'll end up with some red on the results. And the reason for that is we are incrementing the value of A every time through the loop, and we don't want that. So they literally now go in lockstep, but we don't want to. We only want to increment A if we copy the element. So we actually cannot do that. We can't increment both I and A. We have to increment it inside of the conditional. Okay, let's just make sure that we didn't break anything. Good, all green. All right, so I worked through 4 problems. I think it was sum 28, has 22, only 14, and without 10. Turns out that in the project that we're going to be doing over the next couple of weeks, doing this kind of copy is like almost exactly what we need to do. There's going to be a point in which we're going to have an array, and then we're going to do something like delete a value out of the middle. And one way to do that is to make a new array and then copy the values down, but skip over the one that you want to delete. And this is essentially what that is. We're skipping all the 10s, but imagine if there was only one 10. It would essentially be this. And notice also that the problem said you may modify and return the given array or make a new array. So what if instead of making a new array, we just modified the original one? So let's not do this. Okay, so we're going to, let's see, how do we do this? I think we're kind of going to do this the same way, but instead of, we're going to have 2 counters, one that's hopping through the array from 0 to the end, and we have another counter that's essentially going to be keeping track of where to put the element that we're going to copy. But instead of copying it to a new array, we're just going to copy it into the same array. Let's switch back to our picture, and let's do a new, let's see, I think I'll do this by erasing the bottom part. Okay. So what we're going to do here is the 1 stays where it is. The 10 is going to, well, the 10 we are going to ignore. We're going to jump over it, we're going to skip it, and then move on to the 5. And the 5 is going to go where the 10 was. So we're going to replace the 10 with a 5. Okay, and then we're going to look at this one, and we're going to skip over it. And then we're going to look at this 2, and we're going to put the 2 where the 5 was. We're going to put the 4 where the 10 was. We're going to skip this 10. Then we're going to move on to the 6 and put that where the 2 was. We'll put the 1 where the 4 was and the 8 where the 10 was. And then we have to go in and fill the rest of them in with zeros. So this might be a case for, it's a little easier to do with 2 arrays at the expense of having this extra piece of memory that you have to allocate. All right, let's switch back and try this. So if num sub I is not equal to 10, copy the element from num sub I into num sub A. So A is going to keep track of where we want to put something. So I think we can just do that, increment this. But now, when we're all done, we have to write one extra little loop that fills the last bit in with zeros. So here's a case of where we actually do need that value of A outside the loop, because A keeps track of where the next element was going to go, and we need to use that value to know where to start filling in the zeros. Okay, so let's go ahead and put this back int A equals 0. And now we need another loop for int I. Now this is a different I because that previous I only existed inside of the first loop. Is equal to A. I is less than nums.length I plus plus num sub I is equal to 0. So this is going to start our loop counter at the value of A, which was going to be the next available slot, and then fill the rest in with zeros. And then we should be able to return nums. All right, let's give it a try. And I'm sorry if you couldn't see that whole program, it might have been off the screen, so I'll bring it up. So now we got all greens there, so that worked out just fine. All right, so there's the program. All right, so we have 2 loops in this one. One that goes and it copies the elements into the previous spots, and another one that goes and just fills in the rest with zeros. All right, so there's that program. All right, so let's do something a little bit different. So I want to talk to you about what's called the conceptual model of computation. And it's called a model because, you know, it's not really exactly what's happening inside the computer, but it's close enough, and it's close enough to be able to hopefully make writing your programs a little bit easier, because what I really want you to do before you start writing any code is draw a picture. Draw a picture of what it's supposed to look like before the method executes and what it should look like once the method is finished executing. And then what goes inside the method is, what do you have to do to make the before become the after? And to be able to do this, you've got to have an idea in your head about what is going on inside the computer. And again, it's just a model. It's not the real thing, but it's close enough to be able to make your programs hopefully make a little bit of sense. So first of all, in this conceptual model, there's 2 kinds of data that Java deals with. There are primitives and there are objects. You can pretty much boil everything down to those 2 things. Either something is a primitive or it's an object. Now, primitives are things like int, character, Boolean, double. There's a few others, but those are the important ones. And these data types, you can tell that they're primitives because they all start with a lowercase letter. int, character, boolean, double. And objects, or classes, by convention, start with a capital letter. So that's how you, as a programmer, distinguish between either the primitives or the objects. And we just got a question on the chat. It says, will this video be uploaded to your channel afterwards? Yes, this video will be made available after this stream is done. So objects are things like string, JFrame to make windows. What else? There's thousands of them. But what are the ones you're likely to know? How about person? Maybe account. Maybe if you're making a video game, it could be like something like player. Okay, so primitives and objects. Now, primitives inside the computer's memory are what's stored in the computer's memory is the actual value of that primitive. So for example, if I have int x equals 12. Okay, that's a primitive, and we know that because it's int. So there is a box, if you will, inside the computer's memory labeled x, whose type is int, and inside that box is stored the number 12. Likewise, if we have a Boolean called has weapon equals true, then there's a box of type Boolean labeled has weapon, and in that box is the value true. Okay, so far I think this is pretty straightforward. But what if we have an object? So let's use an object like a string. String name equals Sam. Okay, you might think there must be a box somewhere that has the word Sam in it, but that's actually not really the case, at least from this conceptual model's point of view. What we do have is, certainly we do have a box somewhere that contains Sam, and the type of that thing is string, but there's actually a second box. Okay, so we got a second box whose label is name, whose type is string, and what goes inside that box is not the word Sam, but actually what's called a pointer to the actual string. And so in this conceptual model, this string called, this string right here exists somewhere in the computer's memory. And I don't know exactly where it is, but let's guess. Let's say it exists at memory location 5000. So the S is at memory location 5000, the A is at 5001, the M is at 5002. So that's somewhere in the computer's memory. And so inside of that box over on the left-hand side is the number 5000. So the variable that you would think of as holding the string actually just contains a number. It contains the memory address of where the string actually lives in the computer. Okay, but from a programmer's point of view, we don't actually care what the address is. In fact, we may never even know what the address is. So we might put a 5000 there just kind of to make it clear in our minds what's happening. But what we actually do is, rather than put numbers there, is we put an arrow. And that means the same thing. It means that the value that goes inside of that box labeled name is the same number as where the string actually lives in memory. So you can think of it as there's a 5,000 in both places. Another way to say it is that the variable called name points to the string that has the letters SAM in it. Okay, so let's show you another example. Let's say we go, now let's do like player Mario equals new player. Okay, so this is the statement in your program. So what does this statement do? Well, the right-hand side allocates the memory in the computer for all of the instance variables that are required to represent a player. So it might be something like the score of the current player. In the case of Mario, it could be like whether he's small or big, what level he's on, what direction he's facing, and so forth. But what we do know is that there is like a larger box that contains all of that data. Okay, and then there's another box labeled Mario of type player. And again, all that's inside of that box is the address of where the player object actually lives in memory. So if we have another player, let's say we have player Luigi equals new player, then of course we end up with another box that contains the actual player information, and a fourth box that contains a pointer to the player object that holds the information about Luigi. All right, so this statement here, the right-hand side allocates the memory for the object. The left-hand side says, make me a box called Luigi, labeled Luigi. And the equal says, take the address of the object on the right-hand side and store that into the box labeled Luigi. So really, this statement here is no different conceptually than saying int x equals 12. Okay, this statement here says, take the value of 12 and put it into the box labeled x. This statement here says, take the value returned by new player, which is the address of the object, and put it into the box labeled Luigi. That's all it's doing. Okay, so let's move on to another page. And let me show you what a player object or player class might actually look like. So here's one here. So this is a class called player, and in it I'm storing 3 pieces of information: an ID, a name, an array of integers called scores. And then I've got a constructor here that puts values into it. But let's look what happens if I create this object and then let's draw the picture of what it's going to look like. So remember that there's an integer called ID, a string called name, and an array of integers called scores. So what's that going to look like? So we might say player M equals new player. Let's give this an ID of 100 and a name of, let's use Sam again. And the constructor is going to store the number 100 into the object and the string Sam into the object as well. So remember that from what the constructor did right here. Okay, So what does this picture look like? Well, we end up with a box labeled M, and this is going to point to a player object. Okay, but what's inside that player object? Well, let's look at the class again. There's an int called ID, a string called name, and an int array called scores. So we're going to have a box called ID that stores an int. A box called name that stores a string. And a box called scores that stores an integer array. Okay, but in this conceptual model, the ID number 100 does indeed get stored there, but what goes inside of this? Okay, Sam doesn't go here. Sam is actually stored out here somewhere. So here's Sam, and it's a string. And then what goes inside of name is a pointer to it. And then what do you think goes on for scores? Well, it's an integer array, and the constructor says make an array of size 10. So that means somewhere out in the computer's memory is 10 boxes all arranged in a row, numbered 1, 0, 1, 2, 3, up to 9. But those exist somewhere in the computer's memory. And what scores is a pointer to that. Okay, so those 12 pieces of data, the ID number, the name, and the 10 scores, don't actually exist inside of the object. Only the ID number does. The rest of them are just addresses to memory locations outside the object somewhere. Okay, so this is going to be really important. Because what if we have something like integer array x equals new integer array 10. Okay, so this is something outside of the player, right? I'm not indicating here this is part of the player. Just another example here. So I've got a box called x, and then somewhere else I've got 10 boxes. 0, 1, 2, 3, 4, all the way up to 9. And this is of type integer array. Okay. And then later on in my program, I go integer array y. So I declare a variable called y of type integer array. And then somewhere later on, I say y is equal to x. Okay, what happens there? Well, this declaration right here just says, make me a box labeled y, and it's of type integer array, but don't put anything into it yet. So I end up with a box called y of type integer array. Okay. And then this statement down here says, take the value out of the x box, no pun intended, take the value out of the x box and put it into the y box. Okay, so what goes in here? Well, remember what was up here. What was up here is actually a number. It's the address of this array. So what we're doing is we're saying, take the number out of this box and copy it into this box. So if the number 5,000 was up in this box, we're going to put the number 5,000 in this box. So there's going to be 5,000, the number 5,000 in both boxes. And what that essentially means is that y points to the same thing that x points to. So let's say that this array is actually filled in with some values like 5, 2, 1, 6, 5, 8. Okay. If I ask for what's the value of box number 2, it's 1. So we start at y, follow the arrow, and then go to box number 2, and we pick out the 1. Okay, so this yields a 1. And if I ask for what's in box number 2 of x, it's the same thing. Right? Because they're both pointing to the same array. So another side effect is that if I change a value in the y array, I also change a value in the x array because they're pointing to the same thing. In other words, if I go and change this value from a 1 to a 7, then that value is going to change in both arrays. Okay, so this is why this conceptual model is important, because this statement here, y equals x, is not making a copy of the array and then they exist independently. It's making them both point to the same array. In other words, and this is a technical computer science term, y and x are both aliases for the same array. Okay, once you've done this statement and you've made this picture right here, you can't tell from the picture which one was the original variable and which one was the new one. They're both kind of equally important. They're both pointing to the array. So you can't say like x is the more important one or y is the more important one. They're equally important. They both point to it. Okay, so you might be thinking now that if I have an object that contains other objects in it, and then that object contains other objects in it, and that object contains other objects, the picture is going to get wildly complicated. And that's true, in fact. It does. There's pointers all over the place. But having this model in mind will help you when you design your programs and realize that when you do things like do an assignment, all it's doing, this assignment, I don't mean like a computer programming assignment, I mean this kind of assignment, is what you're doing is you're just copying a number from one location to another location. You're just copying the number that was in this box and putting it in this box. That's all you're doing. It's a very, very quick operation. And so this is actually why Java decided to implement things the way they did, of having primitives and objects. Objects are just known by their addresses. When you pass an object into a method, all you're doing is you're passing in the address of that object, not a copy of it, the address of it. Makes it very quick because the address is only like 4 bytes, right? It's just a 32-byte number. So you're just passing in a quick little 4-byte number into a method. You're not passing in a gigantic collection of data into it. But what it also means is that if you pass in, let's say, the address of an array, both the variable that receives it inside the method and the one that is in the caller can both access the array equally. So when you pass an array into a method, be very clear that that method is now allowed to modify that array because they have the address of it. There's nothing preventing that method from messing around with the contents of the array. Okay, so I'm going to wrap up with one last little thing, and that is what I call the purpose of classes. Why do classes exist? So since this is a second semester programming class, you've only kind of had one semester of programming under your belt. And in that class, in that course, they try to just get you through the basics of doing computation, arithmetic, printing things out, getting input from the user. And so what you may think of as being the purpose of a class is to somehow encapsulate some kind of computation that you want to do. Right, so you wrote in a simple program that just took some input from the user, did some computations, and returned the results. And then the whole purpose of the class was just to kind of wrap the whole thing up like a burrito, where the stuff in the inside is the actual program, and the stuff on the outside, the tortilla, is just there to hold it all together. But now that we're in the second semester, we got to now look at why do we make classes in the first place. And I think we can boil it down to two reasons why we make classes. One is we want to store some data, and we want to manipulate that data. So we want to put some data into an object, and then we want to do something to it. Like if we are storing data about a video game player, we want to store ID number, the name of the player, or the inventory, position, and so forth. And then we're going to write methods to manipulate that stuff, like add or subtract from the score, or move the player around by changing the X and Y values. So that's what the methods would do, is manipulate that data. So that's one reason why we might make a class, is we want to bundle together some data, and then we write methods to manipulate that data. But the other reason is to flip that around. What we want to do is create a set of behaviors. So one of the reasons why you write a class is you want to model something that perhaps exists in the real world, or something that's just in your mind. Like I want to model, let's say, a portion of a freeway, right? So I want to model what it looks like for all the cars to be traveling on the freeway, and for cars to be entering and exit and merging lanes and crashing into each other occasionally. And so what I think about is all the behaviors that I want to do. And behaviors, I don't necessarily mean how it acts, but what do I want this thing to do? So if I'm talking about a freeway, and this is just off the top of my head. If I'm talking about a freeway, I might think like, well, one of the things I want to do is I want to add a car onto the freeway. So I need some way to increment the number of cars, or I want a way to take away a car, or I want two cars maybe to exchange lanes, right? So, or maybe I want one car to merge into the lane of another car. And in fact, if I'm thinking about a freeway, you're typically thinking about something that has multi-lanes. So then you start thinking about, well, what kind of data do I have to store to make this set of behaviors possible, right? If I want to be able to add cars to a freeway, I've got to have some way to store all the cars that are in my little section of the freeway. And if I'm going to have several lanes, like a 4-lane freeway, I've got to have some way to store information about those 4 lanes, right? So I think about what I want my class to do, and then from that, I figure out what data do I need to make those behaviors happen. So then determine what data are needed to implement those behaviors. Sorry for my kind of sloppy handwriting. Okay, so those are kind of opposites of each other. One of them is you know what data you want to store, and now you have to figure out what methods you want to manipulate the data. And the other one is you know what methods you want, and now you have to figure out what data you're going to store to make that happen. Okay, so that's really the purpose of classes, is to encapsulate either a set of behaviors or a set of data. But in both cases, you're going to have instance variables, which is the data, and you're going to have methods, which manipulate the data. And what you need to think about is this class gets created and has some initial state, initial set of values. And then every time you call a method, that class moves forward in time, and the data in them changes a little bit. So again, thinking about the freeway, if I start out with initially an empty freeway, and then I add a car, now this class has sort of moved forward in time, and there's a little bit of data in there that wasn't there before. And then I add another car, and I add another car, and I take away a car. And all these methods are moving the object forward in time. So if I sort of take a picture of the object, what I'm doing is I'm saying, this is what the object looks like right now. And then I call a method, and then the object changes. And then I can take another picture of it and say, this is what the object looks like now. Okay, so the purpose of a class is to wrap all this up so that you can now take this set of data and move it forward through time as your program progresses. And how this relates to the assignment we're doing, which is to implement what is essentially array list, is we're starting out with an array. So we're actually doing the first one here. We're going to store some data in an array, and then we're going to write the methods to manipulate that array. And we have to think about, what is it that we want our data to do? Well, I want to be able to delete an element. I want to be able to add an element. I want to be able to sort them, search them. And so what I have to think about is not only what data do I want to store, which is the elements in an array, but is there any other additional information I have to store in order to make those things happen? So that's something to think about. Okay, so what we're doing over the next couple of weeks here is trying to create this class that implements a new set of behaviors, but all we've got to work with are essentially the primitive operations, creating an array, counting things, using loops and conditionals, and we're going to, as much as possible, ideally not at all, use any of the existing Java libraries to make that happen. We're going to essentially write our own from scratch, and I'm going to show you how that's done. So we're not going to rely on anything else that the Java library provides for you. Okay, so that's what I'm going to leave you with. So I hope that you found this hour and 10 minutes or so of review to be helpful. We started out by working some problems with arrays and loops and conditionals, and then I talked about how the data structures inside of a program look with boxes and arrows, and then I talked about what I believe to be the reason why you write classes in the first place, why object orientation exists. And this will hopefully help you with your programs. So I will kind of pause at this moment and ask if there's any remaining questions. I'll wait about 30 seconds or so, and if I don't hear anything, then I'll sign up for the evening and hope to see some of you in my classes.